At 13:47 hours in occupied Zaporizhzhia, 12 Ukrainian drones are screaming toward a Russian ammunition train at 97 kilometers per hour. The operators don't yet know that Russian artillery has already found their position. The first 152-millimeter shell lands 800 meters away, close enough to shake dust from the ceiling. The Russians detected them the moment 48 brushless motors powered up simultaneously. That electromagnetic spike lit up every sensor within 10 kilometers like stadium lights. The operators have a choice: abort and survive, or continue under fire. They have roughly 12 minutes to reach the train. Russian artillery needs maybe 3 minutes to find them. They decide to continue the mission. A BTR spots the swarm and opens fire, tracers arcing through the morning air. The formation splits instantly: 4 high, 4 low, 4 straight through the middle. Machine gun rounds zip through empty space. What the Russians can't see is that each drone trails a fiber-optic cable thinner than a fishing line. While Russian jamming floods every frequency with brute power, these cables carry data at light speed, completely immune. The $10 million electronic warfare vehicle below might as well be a very expensive paperweight. Artillery brackets the area. The operators had prepared 3 separate bunkers spaced 500 meters apart. A 152-millimeter shell is lethal out to about 300 meters. At 500-meter spacing, even a direct hit on one bunker won't affect the others. The Russians could eliminate 1, maybe 2, with incredible luck, but never all 3. Enough drones would always survive to complete the mission. The second round lands 600 meters away, closer, but still searching. Through the lead drone's camera, the operator sees the target clearly now. Black diesel smoke rising from the train. Ahead lies a 2-kilometer straight-through open terrain, too far from strong points, too exposed for close protection to matter. The Ukrainians studied this route for weeks. The window will last exactly 97 seconds. The third round impacts 450 meters away, and this one changes everything. Shrapnel whizzes through the air at 1,500 meters per second and finds the fiber-optic cables of drones 2, 5, and 8. The 8-millimeter lines sever instantly. Those 3 drones switch to backup battery and radio control, now vulnerable to jamming, while the other 9, cables intact, continue transmitting pulses of light through glass at 200,000 kilometers per second. Bunker 1 calls it, "Continue the mission while relocating." The team grabs gear and sprints through a connecting tunnel to a backup position 700 meters east. The 4th shell slams in just meters from the now empty bunker. The guns must reacquire, and that takes time the Russians don't have. Electronic warfare is about to meet its limit. The R330ZH Zhetel, at a rail junction, detects the swarm at 7 kilometers and spools up. 10 kilowatts of electromagnetic energy flood bands from 100 megahertz to 2 gigahertz, enough to overwhelm ordinary drone links, GPS, and radios within 30 kilometers. The 3 radio-controlled drones go dark instantly. Their screens turn to static, but the 9 on fiber keep flying as if nothing happened. Jamming radio waves to stop a fiber-optic signal is like trying to silence a flashlight by shouting. Physics doesn't cooperate. Inside Zhetel's command cabin, the operator watches his waterfall display saturate. He widens the noise, then widens it again, 2.4 to 5.8 gigahertz, every known military band, until the spectrum is a solid wall of hash. He's built a 30-kilometer electromagnetic bubble, yet 9 signals remain impossibly clean. Confusion deepens. He checks gear, recalibrates. Still they come. Jamming is indiscriminate. The BTR-82A at checkpoint 9 sees the swarm on thermal and tries to warn the Pantsir S-1 battery 3 kilometers away. Nothing but static. Russian radios are as dead as Ukrainian ones. In trying to blind the enemy, they blind themselves. Meanwhile, the train engineer, briefed on possible drone activity, pushes the throttles. The convoy climbs from 42 to 48 to 52 and finally 56 kilometers per hour, the limit for 4,000 tons on tired track. But speed creates a new problem. Every kilometer per hour shifts the intercept by 17 meters down track. The operators must recalculate continuously. Each course tweak burning precious battery. The BTR has an 8-second engagement window as the swarm crosses perpendicular at 27 meters per second. The gunner needs to lead 15 meters. He opens with the PKT 800 rounds per minute, but by the time he walks fire onto the path, the drones slip behind a tree line. In simulators, targets behave. In reality, they jink every 2 seconds. Up, down, left, right, like drunk hummingbirds. Fiber lines glint like spider silk in the sun, but you can't shoot a shadow. The commander slams a fist on the turret. Radios are still jammed. He can't even report the miss. Now the Pantsir sees them, not on radar, which filters the tiny signatures as clutter, but on its electro-optical sight. The gunner switches modes and opens up with twin 2 A38M autocannons at 3,200 meters. He isn't aiming at single drones. That's swatting mosquitoes with a rifle. He dials airburst fuses. Each 30mm shell detonates into 400 shards across a 4-meter sphere. At 5,000 rounds per minute, he builds a metal wall. Drone 6 vanishes at 2,900 meters. 3 seconds later, Drone 11 explodes. The remaining 7 scatter in 3 dimensions. 3 climb to 200 meters. 3 dive to grass height. 1 maintains altitude and jinks. The computer recommends the high group. It's easier to track against sky, but doctrine says engage the closest threat first. The gunner has 2 seconds. He chooses the high group, repeating a mistake that cost another train 3 weeks earlier. While his barrels chase skyward, the low group sprints toward the rails. He realizes the error, but can't traverse back in time. More guns join in. At Observation Post 7, 40 AKs fire synchronized bursts, but the drones are crossing at 27 meters per second. At 200 meters, each passes through a sight picture in 0.74 seconds. Human reaction absorbs a quarter second. Aiming eats half a second more. By the time a finger tightens, the target is gone. 4 special drones that had been loitering at 500 meters dive 800 meters behind the locomotive and release thermite charges onto the rails. Thermite isn't an explosive. It's aluminum powder and iron oxide that burns at roughly 2,500 degrees Celsius. Railroad steel softens and fails near 1,370 degrees Celsius. In seconds, 4 segments of track sag into glowing puddles. The cut will matter in minutes. The Pantsir's barrels glow cherry red. Autocannons can sustain max rate for about 45 seconds before heat warps rifling. Then rounds tumble and accuracy collapses. The gunner must cease fire to cool. A 12-second window opens, an eternity in combat. The 7 drones push through. Battery warnings flicker amber. Headwinds and constant course corrections drained more than planned. Drone 3 shows 18%. Drone 7, 21%. They need 30 seconds of flight and may have only 20. Then the battlefield gifts them smoke. Grass fires from thermite drift across the line of sight. Thermal imagers pierce night and rain. but smoke's carbon absorbs across IR bands. For crucial seconds, every Russian post loses the picture. The drones punch out of the smoke at 1,400 meters. Cameras resolve stenciled warnings. Wagon 22, Class 1.1 explosive. Fiber cables near maximum extension. At 12,000 meters, they dump automatically to prevent snags. 10 seconds to release. 5, 3, 2. The first spring-loaded spool clicks free 13 meters early. Drone 1 falls to battery at 8%, perhaps 18 seconds left if everything behaves. The others release in a 3-second cascade. Now they're free and no longer immune to jamming, but too close to stop. 153 meters from impact, closing at 27 meters per second. The engineer sees 7 black dots swelling in the windscreen. He slams the throttle past the stops, redlining diesels. But harder isn't faster. Steel-on-steel friction drops from approximately 0.78 static to approximately 0.25 once the wheels slip. The drivers polish the rails instead of gripping them. The train actually loses 2 kilometers per hour. The Panzer tries one last engagement, but the drones have crossed inside minimum range, about 500 meters, where the guns can't depress beyond -5 degrees. Designed for missiles and aircraft from above, the system has no answer for ground-skimming threats. $20 million of air defense defeated by trigonometry. The gunner watches as 7 blips dip below his envelope. At the final checkpoint, rifles, machine guns, even RPG-7s used as makeshift flak, rip the air. It doesn't matter. The drones fly the exact center line of the rails, using 600 meters of train as lateral cover. To hit them, soldiers would have to shoot through their own wagons. Drone 3's battery dies at 100 meters. The motor quits, props windmill, but momentum carries it like a thrown hammer. At 97 kilometers per hour with low drag, it will glide the last stretch, calculated to the meter. Through the last functioning camera, an operator watches combat engineers attempt to decouple Wagon 22 while rolling. The coupling sits under the tension of 4,000 tons at 56 kilometers per hour. The safety design will not release under load. It prevents catastrophic separation. They are trying to untie a steel knot dragged by bulldozers. Drone 9 catches a lucky burst. Shrapnel clips the battery. It tumbles into wheat, 400 meters short. 6 remain. The team assumed 60% losses from the start. 4 hits suffice for mission success. The margin is still positive. At 13:59, the lead drone slams into the coupling between locomotive and first wagon. An RPG-7 warhead detonates, the shaped charge jet's molten copper at roughly 2,800 meters per second, shearing the massive coupling pin instantly. 4 more impacts follow in precise sequence. Wagon 3's fuel valve assembly ruptures, spraying pressurized diesel. Wagon 7's brake line severs, locking every trailing wagon. Wagon 18's thin-skinned ammunition car takes a direct hit, igniting secondaries. Wagon 22's ventilation intake is punched at 13:51 and 18 seconds. Inside Wagon 22 sit 12 tons of TOS-1A thermobaric rockets, their seals vibration-worn and heat-soaked. The impact edges internal temperature past auto-ignition. The fuel-air mixture detonates. A pressure wave propagates at 3,000 meters per second. Wagons 20 through 24 cease to exist, vaporized into incandescent debris. The blast lifts wagons 25 through 47 off the rails, flipping them end over end across fields. A mushroom cloud climbs to 1,400 meters. In 4 seconds, $4,800 of modified racing drones erases $127 million in Russian military assets and severs the only rail line feeding 3 mechanized divisions preparing for tomorrow's assault. The rails behind the fleeing locomotive are molten gaps, its brakes locked by severed lines, its consist shattered. Jammers silenced their own radios. Air defenses chased the wrong targets. Guns overheated. Geometry and timing, not size, decided the fight. The operators, dispersed and alive in their bunkers, watched the feed fall to static, then to triumph. Mission success bought by fiber, thermite, and audacity. Bye for now.